Quantifire. Cellular beams module. In this video you will learn about how to enter and assess beams with web openings, or as they are often referred, cellular beams. This will include entering beams made from fabricated plate sections and made from serial sections. It will also cover entering beams with defined failure criteria and using Quantifire's cellular beam calculator. These types of structural sections need careful consideration when determining thicknesses of fire protection, since the steel between the openings, known as the web post, can often heat to a higher temperature than an equivalent solid web section. This is due to potential for heat to conduct into the section around the edges of an opening, after, for example, possible peel back of an intumescent. Users should also be aware that industry default temperatures for solid web beams are not appropriate for cellular beams. The introduction of an opening in the web requires additional structural failure modes to be checked when the beam is subject to an applied load. The result is typically a comparatively lower temperature. After logging in, you will see your permissions relating to cellular beams. In order to use Quantifire's built-in cellular beam calculator, you must be using a CB license version of the software and be authorized to use the module by your appointed administrator. When selecting products, look for the reference to cell beams in the product description. This indicates that the product has been tested on cellular beams and that the associated dataset is contained within Quantifire. Be aware that British Standard and European cellular beam fire testing datasets are typically not published in the public domain. Cell beam datasets in Quantifire are held in private databases which reside with the license holder. Manufacturers may, at their discretion, extend access to the private databases to select customers using an external version of Quantifire. To enter a cellular beam, click on the Custom Section button and then the Cell Beam tab at the top. Quantifire allows you to enter a cell beam built from serial sections or fabricated from plates. Let's look at some of the ways to enter these sections. Let's start by entering a fabricated section formed by a series of plates. Click the T's as Plates option button and enter the plate dimensions accordingly. In this example we'll assume an overall beam depth of 620 mm, flange widths of 200 mm, a web thickness of 10 mm and flange thicknesses of 20 mm. Now let's consider cellular beams formed from serial sections. Let's assume the scenario of a serial section which has holes cut in its web. Let's assume it's AUB 406 by 178 by 60. Enter this section as the top T and then click the check button to the side. This denotes that the parent section is an unmodified serial section. When this button is ticked, note that the bottom T and the overall beam depth are automatically updated. Note how the equivalent dimensions are populated in the text boxes and that the web and bottom flange section factor are automatically calculated. Some cellular beam manufacturers use their own designation to describe the cross-section profile of a cellular beam. Let's consider the following designation: 650 by 191/210 by 94.5. This means that the beam has an overall depth of 650 mm, its top T is 191 mm wide and its bottom T is 210 mm wide. The 94.5 refers to a linear weight of 94.5 kg per meter, and this value is the average weight of the parent top and bottom T serial sections. These are typically made from UK universal beams and universal column serial sections. With a bit of detective work and cross-checking of steel tables, it is possible to figure out the top and bottom sizes. Quantifire simplifies this to assist the user. Click the T-Finder button. Enter the designation and click Find Top and Bottom T. The software automatically determines the top and bottom T. Note that some designations in this format may yield more than one potential combination of top and bottom T. In this instance, clarification should be sought from the originator of the information. Upon clicking OK, the top and bottom T's are automatically populated in the relevant input boxes, together with the overall beam depth. Finally, let's consider the direct entry of an asymmetric beam made from two different upper and lower T's and based on serial sections. The beam has an overall depth of 533 mm. The top T is AUB 406 by 140 by 46 and lower T is AUB 406 by 178 by 67. These are entered in the input boxes accordingly. Cellular beams can be treated as three-sided or four-sided. We will leave it as three-sided for this example. To the right of the input form you can enter more details about the beam. The opening shape can be selected at the top. If you are given the failure criteria, then these can be entered next. Failure criteria may be given by the manufacturer of the beam or as part of a structural fire engineering assessment. Click the checkbox to input the failure criteria. In this example, we will enter that it is a web failure mode, the web post width is 250 mm, and the web failure temperature is 587 degrees Celsius. We've not been given a bottom flange failure temperature, so in this case, we will assume the same temperature as the web. If we wanted to modify the section factors in any way, we can tick the checkbox to their values to unlock them for editing. If you are not given failure criteria, then you can either enter an industry default temperature specific to cellular beams for both the web and flange and select the failure location to be unknown. In the absence of opening geometries to determine web post width, a common approach is to adopt 130 mm to align with the minimum required for fire testing. The proposed section designation contains all the pertinent information needed to determine a thickness of fire protection. The CB denotes cellular beam. Then the dimensions of the beam are defined. The C denotes circular openings. The WP is the web post width. The SF refers to the section factors of the web and flange. The T is the failure temperature of the web and flange. Finally, the F denotes the failure mode, which in this case is W for web. To enter the section, we can either click Quick Insert to use the currently defined inputs. For example, the zone, the beam's quantity and length and the fire resistance period. Alternatively, we can click OK, make any other modification required and then click Insert Section when ready. The thickness of fire protection is then determined based on the defined beam inputs and specified failure criteria. Users with access to the Quantifire CB license can let the software determine the failure criteria directly. Let's illustrate this with an example. Let's consider the last asymmetric beam example from earlier. We will assume circular openings and click OK. We know that the beam is 12 meters long, so we can enter that directly and click Insert Section. Note now that the critical temperature reads Q plus CB. This indicates that the beam has been subject to a protected assessment, or in other words, for the given thickness of fire protection, a thermal map has been created on the beam as part of its structural checks. As such, it is not possible to define the beam with respect to a single temperature. You may be thinking, how has a thickness been evaluated when no openings have been specified yet? The answer is that Quantifire uses customizable defaults to speed up the process. Let's take a look at these now. Click on the Quantifire logo to access the main menu and then click on Edit Advanced T-Crit Default Settings. This opens the dialog box for all the advanced critical temperature calculations. When the Advanced T-Crit Calculator option is set and the user clicks Insert Section, all the relevant settings in this dialog box are applied. These can be changed at any time, but on first opening of the software they are set to be conservative as much as possible. Members are loaded to a utilization of 65% at the accidental limit state of fire, which is a recommended value in the Eurocodes, while the steel is set to be grade S235. The Beam tab has information relating to span, spacing of adjacent beams and composite decking inputs. Note that a re-entrant deck is assumed by default. The Beams with Web Openings tab defines the opening geometries to be considered. By default, circular openings are considered with a web post width of 130 mm. Click on OK and then Accept and Close. Let's look at the beam a little more closely. Click on the T-Crit Editor button and enter the beam's ID number. This opens the Cellular Beam Calculator where we can see the full detail associated with the beam's inputs. We can see an image of the beam's openings and can confirm that Quantifire has automatically populated them to ensure the default web post width of 130 mm. In this case, it equates to diameters of 426 mm at a spacing of 556 mm. The results of the assessment are summarized on this page. We can confirm that the beam has been pushed to 65% utilization, or rather a unity factor of 0.65 at the fire limit state. The unity values for all the structure failure modes are shown. Web post buckling is shown to govern at both ambient and at elevated temperature. At fire, the critical web post is between opening 1 and opening 2, it has a circular opening either side and its width is 130 mm. This equates to a web failure mode and occurs when the critical web post is at 461 degrees Celsius when protected with 5.36 mm of fire protection. Let's now consider modification of the beam's design. The openings can be changed in a number of ways. The user can type into the table directly. Let's delete the last 5 holes and replace them with a single rectangular opening of depth 300 and length 600 mm at a center-to-center spacing of 1200 mm from the previous opening. Now let's add an elongated circular opening of depth 250 and length 800 mm, again at a spacing of 1200. By clicking on Balance End Posts, all holes are centered on the beam such that the left and right end posts are equal. To define regular openings quickly, use the Generate Regularly Spaced Openings button. Assuming circular openings, we can put as many openings as possible into the web in accordance with design guidance limits. In this instance, we get a warning message to indicate that the resultant web post of 128 mm is less than the common limit of 130 used to define cell beam datasets, or in other words, a protected solution may not be possible. Alternatively, we might specify a spacing ratio, for example, holes are spaced at 1.6 times the opening height. Quantifire determines the maximum possible opening height and spaces the holes accordingly. If we know the web post width, then we can specify this directly and let the software position the holes. In this example, let's set it to be 500 mm. The same approaches can be used for rectangular openings. To continue with the example though, let's assume we are told that they are circular openings with a diameter of 450 at a spacing of 750 mm. We enter these and Quantifire shows us the resulting beam with web post widths of 300 mm. Now let's set the grade of steel to be S355 for both the top and bottom tees. Let's also change the loading type to be ultimate limit state ULS utilization at 100% with an assumed permanent, or rather dead load proportion of 50%. We will also change the partial safety factor for variable or imposed loads in fire to be that set in the UK National Annex for an office occupancy. We can now click on Assess Beam and we see that the ULS unity ratio shows 1, with veer in deal bending at an opening governing at ambient. In fire though, web post buckling governs. The critical web post temperature at failure in fire is 570 degrees Celsius and this occurs with a DFT of 4.17 mm. We can interrogate the beam further by clicking on Generate Report. Since this is a protected beam assessment, it is using potentially commercially sensitive web post factors and elemental product thicknesses. It therefore prompts the user as to whether this information is to be included on the report. We will say yes in this instance. We are now faced with a printable report which can be used with designers, approving authorities or other project stakeholders as required. The report sizes all inputs, beam geometries, loading conditions, ambient checks, fire checks and product information. At the start of the fire checks, the temperature distribution across the beam is displayed. This is the information that is hidden if the user chooses not to display it. The report is approximately 10 to 11 pages in length and concludes with an overall summary which includes the fire protection requirements. Let's close the report and go back to the calculator. When the beam is finalized and assessed, click the Accept and Return button. The resultant DFT is now updated and all inputs relevant to the beam are stored on a member-by-member basis for further refinement of the assessment or reporting as required. This concludes Beams with Web Openings module tutorial. We hope that it's provided you with an overview of how to consider a cellular beam and has helped to guide you in undertaking an estimation project where they are included. Full information on beams with web openings is given in the Quantifire User Guide and the Cellular Beam Quick Start Guide. Look out for other cell beam related topics in other training videos, including the bulk importability and their automated structural fire optimization.